All right, welcome to Spotting and Sidestepping Decision Traps, making strategies for smarter decisions. My name's Chris Seifert. I'm going to be talking to you today about decision traps, just real briefly about myself. I know you're more interested in the topic than me, but just so you know who's talking to you, my name's Chris Seifert. I have over 25 years of operational leadership experience and experience advising executives in manufacturing, chemical industries, oil and gas. Spent 8 years on active duty in the Navy. That is me on the right in the picture there on the fast attack nuclear submarine USS Asheville during deployment a little over 20 years ago. Over that time, I've had the opportunity to train and mentor over 2,000 leaders. I have either made or been involved in making over $500 million worth of capital investment decisions and been in many large culture transformation and business transformation projects. So, look, on to our topic for today. Today, we're here to talk about decision traps. A decision trap is just a mental shortcut that we take when we're making decisions. So, just a few examples of some of these. If I was to ask you, how do you pronounce the capital of Kentucky? Would you tell me you pronounce it A, Louisville, or B, Louisville? So if you'd like, go ahead and you think about that for a minute. Put your answer in the chat there. You think it's A, Louisville, or B, Louisville? All right. Yeah. Well, look, the correct answer is none of the above. You pronounce the capital of Kentucky, Frankfort, because Louisville, however you want to pronounce it, that's not the capital of Kentucky. And look, if you were pretty sure it was either A or B, or maybe you thought, no, it's Louisville, you're not alone. The vast majority of the people, even people who live in Kentucky that I've asked this question to, will defend one of those two answers. And then when I remind them that it's actually Frankfurt, they'll say yes. So what's happening here, right? This is called the framing trap. The way that a problem or a question is framed shapes how we answer it, our judgment and our decision. So it's just the way that it's shaped. If I had asked instead, what is the capital of Kentucky? You might have been more likely to come up with Frankfurt rather than default to one of the two options that I gave you. Here's another example. Let's say Ronald is either a librarian or a salesman. His personality can best be described as reserved. It's no doubt that he is an introvert. Is Ronald more likely to be a librarian or salesman? So, just based on that description, if you had to pick, would you say that Ronald is more likely to be a librarian or a salesman? All right. Now, most people would think, well, if I was to think about a librarian, I would think generally they probably are more fit to be somebody who's quiet. Where if you're going to be a salesman, you probably need to be an extrovert. You need to be like to talk to people. Probably sounds like Ronald is a librarian. But what if I asked you how many librarians are there in the United States versus how many salesmen, right? I mean, I have to imagine there's probably like 10,000 salespeople for every one librarian. So is it possible that there are some introverted salesmen, even if salespeople are more likely to be experts? What if all the introverted salespeople in the world were added up? I bet they would come up to the more than the total number of librarians. But our brains don't think about any of those kind of statistics, right? In reality, it's probably more likely that Ronald's a salesman, but our brains don't do statistics and math particularly well. Okay. So here's another example. If we were to have a debate about whether or not cats or dogs are better, and I was just to go out there and search on the internet and say, I like dogs. I'm going to win this debate. I'm going to ask the Google machine, are dogs better than cats? And here's what Google's going to tell me. It's going to tell me 8 reasons dogs are better than cats, 20 reasons why dogs are better than cats. And look at that, 11 scientific reasons that dogs are better than cats, right? Now, what if I was more of a cat person going into this debate? And so instead, I searched first for, are cats better than dogs? Well, now I get 10 reasons why cats make better pets, why cats are better than dogs, 16 reasons, 10 reasons why cats make great pets. So what you can see here is that the way that I ask the question, the way that I go looking for evidence in this case, tended to confirm my bias. If I prefer dogs or I prefer cats, and so I allow that to shape the way I investigate or do research to either confirm or disprove what I believe, the way that I ask that question has a profound impact on the answer that I'm going to get. And that's called confirmation bias. And it's another common decision trap. And one last one. So let's say there's been a study done, and that study says that the incidence of kidney cancer in 3,141 counties of the United States reveals a remarkable pattern. The counties in which the incidence of kidney cancer is the lowest are mostly rural, sparsely populated, and located in traditionally Republican states in the Midwest and the South. So if that statement was true, right, you might think, well, I could kind of make sense of that, right? Seems like, well, I could see some articles, right, being written on study says good moral values lead to lower incidence of kidney cancer, right? These nice, good, wholesome Midwest towns, right? Those good moral values lead to less cancer. Or, hey, the clean air in these rural towns is leading to less cancer. Or, veggies, eat your veggies and you will be less likely to get kidney cancer, right? We can see all the newspaper articles coming out of this study, right? What if I told you not only is that true, but it's also true that the counties in which the incidence of kidney cancer is the highest are also rural, sparsely populated, located in traditionally Republican states in the Midwest and the Southwest. And you could probably also think, well, oh yeah, sure. I mean, I can again, the newspaper articles make sense, right? Kids are dying of kidney cancer because all these Republican counties have poor health care, right? And the poverty, obviously, poor counties equals more cancer. And all the fried food that people eat in the South equals more cancer, right? So I mean, we can see all these articles coming from this study, and both of these facts are true. How can it be true, right? Why would it be true that both the highest and lowest incidences of kidney cancer are both found in rural, sparsely populated, traditionally Republican states in the Midwest, South, and West, right? Well, the answer is because the law of small numbers, right? When you have small sample sizes, so counties with small populations, a few cases, more or less than the average, is going to result in significantly bigger changes in the incident rate. So it has nothing to do with whether they're Republicans or whether it's in the South or the Midwest or whether they're have good clean living and they're eating vegetables and clean air. What it has to do with is just variation in statistics. That's it. Right. So these are all examples of decision traps, right? Things that can cause us to interpret information, make bad judgments, make decisions. So let's take some time to understand that. Because I think if you understand what's going on in your brain, then you're better able to hopefully recognize that these things are happening to you. So, right off, when you see this picture, what do you think? If you're like me, right away, pops into your head, ooh, she looks angry, right? She doesn't look happy. I've done something. I'm probably about to get yelled at, right? So, if you look at this next image, 17 times 24, what do I think? I think right away, I think that's a multiplication problem, right? I could probably do that in my head, but, if I was to calculate it, that's actually going to require some effort, right? So, whereas it requires almost no effort to interpret this picture really quickly, it required no energy, no thought. It was unconscious, even for me to think of, wow, she's angry, she's upset. Didn't require any effort, no energy, no concentration. I didn't even think about it, right? It wasn't based off any actual data, though. It's just I've seen lots of angry people, and so she looks angry to me. And I could probably be making a lot of those kinds of decisions at one time, right? So we'll kind of call that those kinds of thinking, the kind of decisions and judgments that we make. Um, like when we look at this picture, we'll refer to those as system one judgments. And we'll think of the other kind of system two is that math problem when I have to actually start to use energy, right? If I was going to actually do 17 times 24 in my head, I'm going to have to stop doing other things. I'm probably going to have to close my eyes and concentrate. My heart rate's probably going to go up a little bit. I'm going to have to sit up in my chair a little bit. There's effort involved in making this decision. And so those system two decisions are the kind of decisions we make that are slower. They're deliberate. They require conscious reasoning. They're cause and effect thinking. We have a small capacity for these. We can't be making multiples of these kinds of decisions at a time. They require effort and control and deliberate thought. So we have these two kinds of systems. So let's talk a little bit about how they work together. So here's an example. If you look at this image on the screen and you see, what do you see on the left? If you're like me, you see the letters A, B, and C. And if I look at the box on the right, I see the numbers 12, 13, and 14. But if I look closer, really close, what you'll notice is that the shapes in the B and the 13 are exactly the same shape. But when we just look at them initially, they take on being a letter or being a number based on the context that surrounds them, right? But again, it doesn't take any effort for that to happen. So I want you to think about system one function, a function of system one, because system one is always trying to come up with an answer as quickly as it can. So one of the things it does to do that, to simplify things, is it just takes things into context, right? It interprets what it sees in the context of what is around it without requiring any effort to do that. So it looks at that shape, it sees an A and a C, it simplifies things and says, well, I must be picking from letters. Or when it looks between the 12 and the 14, it says I must be picking from numbers, right? And it simplifies it. So one of the simplifying functions of system one is to take things into context. Similar for the statement in the middle, and approach the bank. That what pops into my head, what system one will interpret, depends very much on where I'm at. If I'm downtown in the city, surrounded by high rises, the thought of a financial institution will probably pop into my head. If I'm sitting by a lake on a nice sunny day, the bank of the lake is what's going to pop into my head. Okay. So that's one of the ways that system one and two work together. Okay. Just another example. So let's consider this problem. A bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the bat and the ball cost? Okay. I'm sorry, how much does the ball cost? Right? So if the bat and the ball cost $1.10, the bat costs $1 more than the ball. How much does the ball cost? Okay. Now, if you're like most people, 10 cents kind of just pops into your head, right? Just the way it's written, right? Well, the bat and ball costs 10 cents. The bat costs more than $1. The ball must 10 cents, right? So the ball costs 10 cents, bat costs $1.10. But if you start to check the math, okay, well, if the ball costs 10 cents and the bat costs $1 more, that means the bat costs $1.10. 10 plus $1.10 is $1.20. Oops, wait a minute, that didn't work. So then you go back and you get to, well, it must be 5 cents, because then it would be, the ball would be 5 cents, the bat would be $1.05. The bat and the ball cost $1.10. So 5 cents is the answer, right? So, but to show you the way that your brain thinks, because most people, your first instinct is to say 10 cents. The way your brain thinks, system one wants to, again, very quickly come up with an answer. And because of the way the question's worded, $1.10, the bat costs $1 more than the ball. How much does the ball cost? It's real simple for system one, which is not good at math, to just subtract $1 from $1.10 and tell you the answer is 10 cents. And that sounds good to you, right? So system one comes up with that answer, just like we talked about before, as quickly as it can. System two's job is to check the answer of system one and say, does that answer make sense? Does that sound right? If system two is engaged, system two will add it up together like we did and go, wait a minute, that didn't work. And then system two will engage and get to the correct answer. So just want to understand, this is the way the two systems work. System one comes up with an answer as quickly as possible. System two checks the answer and corrects it. Okay. And I share this image with you just to illustrate one final point here. So if you look at this picture and I said to you, which of the three people in the picture appears to be the largest? I think for most people, the one on the right hand side of your screen appears to be the largest, right? But if I told you, if we got a ruler and held it up here, what you would see is that they're actually all three exactly the same, right? So what's going on there? Well, what's happening is that your brain has learned over time that converging lines indicate distance. And because that third person on the right is closer to the converging lines, our brain says, well, that person must be further away from us. And so, since they're actually the same, they are the same size, our brains are correcting them to make them appear bigger because it must be bigger because it's further away, right? That's what's happening. Now, even though I just explained to you this, again, simplifying shortcut that our brains take and our brains have learned, even though I've just explained that to you, and you know for a fact now that all three are the same size, even still, when you look at that image, the person on the right appears to be bigger, right? And so the reason I emphasize this and share this with you is to make the point that even though I'm explaining to you how these decision traps work and the fact that our brains take these mental shortcuts, even once you know your brain takes these mental shortcuts, it still takes these mental shortcuts. And there's nothing you can do about it. You can never unsee the person on the right being bigger, right? You just can't see it. It's how it appears, right? So this is how our brains work. And a lot of what I'm sharing with you comes from a book called Thinking Fast and Slow by Daniel Kahneman. I would highly encourage you to read this. If I was picking 5 books that have changed the way I think and look at the world and do things, the Bible would be on that list. Thinking Fast and Slow would also most certainly be on that list. In that book, Daniel Kahneman explains that the measure of success for that system one part of our brain is to come up with a coherent story as quickly as it can, right? System one simplifies this by making some assumptions. One of those is what you see is all there is. You don't need any more information than that. The job of system two is to monitor system one, but system two is lazy, right? It has to be lazy. If you think about it, system two can't be constantly stopping and correcting us. If you think about just driving down the road in your car every day, system one is constantly engaged making decisions about, is the person behind me too close? Do I need to speed up or get out of the way? Or is the person in front of me too close? Do I need to slow down? Is the person to the right of me staying in their lane? Do I need to turn right here? What do I need to do? Right? All these are system one decisions. If system two was constantly engaging, you'd be stopped in the middle of the highway and you wouldn't go anywhere. So system two needs to be lazy. Most of the time, that's great, right? So this causes, we jump to a lot of conclusions because of this. And most of the time, like when we're driving, that's good, right? We wouldn't be able to do what we need to do if we didn't. However, in high risk situations, the problem is, when there's a lot of uncertainty and a lot of risk, these decision traps can lead to really bad consequences, right? And so I think that applies more when we're doing things like working, right? When we're in a business, we're making decisions about, a lot of times we're having to predict what we think is going to happen, what our competitor or a customer or, partners are going to do in the future, or what trends are going to happen. And we're having to make all kinds of decisions where there's lots of complexity and uncertainty, right? And so unfortunately, these decision traps in those situations can be very harmful. And as Kahneman points out in his book, right, he says, unfortunately, just like if you think about the picture with the 3 people, we can't undo this. This is the way our brains work. So the best we can do is a compromise, he says. The best we can do from his perspective is learn to recognize situations in which mistakes are likely and try harder to avoid significant mistakes when the stakes are high. So in other words, Kahneman is saying that we can't avoid the decision traps. They're how our brain works. They're part of it, or they're going to happen. We can avoid the consequences, though, by knowing that when we go into making decisions where there is a lot of complexity, a lot of uncertainty, a lot of risk, we are more prone to be susceptible, and his mind say, can try harder not to fall victim to those decision traps, right? Now, at Enabling Empowerment, we actually believe you can do a little bit better than try harder. What we have done, what we believe in using is a very specific decision making process that helps us avoid a lot of these decision traps, right? We believe that by teaching people to use this process and getting really good at it, we can avoid these different traps. And so, outside the scope of today we're here to talk about the decision traps, right? And help you understand how they work and tell you that there is a tool. We're not going to go into detail in it, but to say this is how we avoid them. And as you can see from this graphic here, our decision making framework really just lays out here the steps, right? What the key things that we do in each of those steps, what are the key questions we're answering, what are the objectives of that step, and what are some of the specific decision traps that we're looking to avoid. So if you're interested in learning more, I can't recommend Daniel Kahneman's book enough. I will say he is a Nobel Prize winning economist, though. I have written a book, Enabling Empowerment, a leadership playbook for ending micromanagement and empowering decision makers. And in that book, I walk through how I've used the decision making framework in my career to personally develop myself and also to teach my teams how to be better at making decisions so that I could empower them to make more decisions. And the book goes through what decision traps are, how to use the framework, different, very specific strategies you can take during each step of using the decision making framework to avoid decision traps. So that's available on Amazon. I highly encourage you to go pick up a copy. I think actually, if you get over there in the next 24 hours, it's still 99 cents on Kindle, but please go pick up a copy. Or if you're interested in learning more about that framework or specific blog articles on decision traps, individual decision traps, you can go to our website, www.enablingempowerment.com. So that's all we had to cover today. Hopefully that was helpful for you. You got something out of that. Would love to hear more. You can reach out to us on the website or through LinkedIn. So thanks again.